This is my first example under Projectiles, which is taken from April 2013. Now let us look at a step of how you solve stupid phone. Stupid. You wait. Hello everyone, this is your first example under Projectiles that I promised you taken from April 2013. So step by step, let us look at how you solve the problem on your projectiles. Now, let us start the program. A player kicks a ball at an angle of 20 to the horizontal with an initial velocity of 20 meters per second. They are required to calculate the time taken for a maximum. So it's a maximum vertical distance. So your maximum height should be maximum vertical distance. Second, they want you to calculate your maximum height it reached. So a time taken and the time for your maximum height. And then the last one, a horizontal displacement, meaning they want your range. So they want those 3 items. Number one, let us look at write your data down, your initial velocity. Every time, your initial velocity is 20 meters per second. Since we will be dealing with your maximum height, your initial velocity will be 20 sine 20. You always use your velocity as your vertical component. So it will be 20 sine 20. And then you also know your acceleration is negative g, so it's negative 9.8 if you're dealing with a vertical movement. Since it's a maximum, it means your final velocity is also 0. So these are the 3 things that you have. You need to write down what you have, and then here's your 3 equations. Three equations that you have. Check which equation you can use your first to find your time. You do have your initial velocity as 20 sine theta, you do have acceleration, you do have your final velocity. Under your 3 equations, that means you can use your first equation. This is your first equation, second, third. If you want time, you use your first equation because you do have a final velocity, you do have an initial velocity, you do have acceleration. The only thing you don't have is time. So V is equal to U plus AT. U is 0, V is 0, U is 20, sine 20, plus acceleration is negative 9.8 time. Make T something of the formula. T will be negative 20 sine 20 when it go on the other side, divided by negative 9.8. You get your time taken for your maximum height. Your calculator should be in degrees once more. 20 sine 20 over 9.8. So it's 0.7 seconds. That's the time it took to reach your maximum height. It took 0.7 seconds since your time was in meters per second. Now, the second one, they want the maximum height. This was the time taken now, the distance, the maximum vertical distance. Again, under your three equations, you consider that you can use the second equation. V squared is equal to U squared plus 2s. Even the last equation, you can use it. So you do have time it take, which is 0.7. So both equations are applicable. This is number 2. V squared is equal to U squared plus 2as. Final velocity is 0. Initial velocity will be 20 sine 20 all squared plus 2 times negative 9.8, and then s is your height. Make h as subject of the formula once more. Negative 20 sine 20 all squared divided by negative 2 times 9.8. Then you get your maximum height. Your maximum height is 2.387 meters. So you just, the only thing you need to remember are just your initial velocity, your acceleration, which is negative 9.8 if you didn't meet your vertical height. If it's a maximum, then your final velocity is 0. Lastly, they want your horizontal displacement. They want your range. What is the data for your range? You have initial velocity as 20 cos 20. Acceleration is 0. Time is 2 times time for height, meaning your time is 2 times 0.7 seconds. With your three equation, since you have acceleration, this equation is out. Second equation is out. Your acceleration is 0. Only your last equation you can use. S is equal to ut plus half at squared. Acceleration is 0. That one is gone. S is equal to ut. What is your initial velocity? It's u cos theta, which is 20 cos 20 times 2 times 0.7. You already calculated your time is 0.7, and you know for your range your time is twice. Then you get your range. (26). That was your range. So you just have to apply your basic principle. Your initial velocity, what is your initial velocity? For your horizontal distance, it's always cos theta, u cos theta. Vertical, it's always u sin theta. You just have to master these little principles. Lala, you need to master this, the eclipse principle, then this will be easier for you. These are the first examples. You'll find the next example under your projectiles and the last two examples under your kinematics. Thank you for watching.